Hi, it's me. So in this set of videos, we're going to talk about how inheritance in Java allows us to have this really nice property known as subtype polymorphism. So let's start by talking about what polymorphism is. So it means providing a single interface to entities of different types. A little mysterious. Well, let's see a specific example. So let's suppose we have a variable dec so that's the name of the variable, and it's of static type dec. So whenever you call dec.addFirst, you know that you're getting a thing, whatever it may be, appended to the front of a double-ended queue. It could be an array-based dec under the hood, or a linked list dec, or something else, but there's only a single call you need to know about, a single interface that can access entities of different types. So in this case, the different entities would be array dec, linked list dec, and so forth, and the interface would be all the methods that are commonly available. Okay? And so what subtype polymorphism is it says that the difference in terms of which method gets called is based on which actual type the object has, right? So in Java, we used the terms compile time type versus runtime type. And so what we said was, whenever you call add first, the actual thing that happens, that is being put in an array versus being put into a linked list, will be based on the runtime type. We had something called dynamic method selection, which is discussed in that earlier video. And that there says that the polymorphism you get is based on subtypes. So whatever the runtime type is, whichever subtype you have, you'll use that overridden method. Now there are other types of polymorphism. We're going to see an example in a moment, but if you want more, there are other classes at Berkeley, for example, CS164 that discuss this, and there's also a wonderful Wikipedia article here you can check out. But let's see an alternate example. So let's see why polymorphism is even a big deal. Suppose we want to write a program that prints out the string representation of the larger of two objects. Okay? So a way we might do that in a Python-like language might be something like this. We have a method called printLarger, or a function, and it takes two objects. It takes a compare function, and it takes a stringify function. We then say, if the comparison of x and y comes out to say that x is larger, so that's apparently the semantics of the compare method, that it returns true if the left argument is bigger than the right. In that case, we'll return the stringification of the x argument. Otherwise, we'll return the stringification of the y argument. So this is an explicit higher order function approach, and what it does is it gives you a common way to print out the larger of two objects. In this case, you also have to provide two functions, and so sometimes these are known as callback functions. Now we're not going to see callbacks at any point in Java, I don't think, probably not, and so as a result, this isn't a pattern that you're going to see much here. But you will if, for example, you go programming in JavaScript. This style of programming with explicit callbacks is fairly common. Now, another approach is the subtype polymorphism approach. In this way, what we do is we say print larger of two objects, and we simply say if x is larger than y, we'll return x.string, let's say. Otherwise, we'll return y.string. And so in this language, which has semicolons for some reason, whereas this one doesn't, I don't know, I just made it up. In this language here, what happens is the object itself makes the choices. This right here, we have subtype polymorphism. The actual larger than function that gets called is based on what x and y actually are. And so this approach here, I find a little cleaner. It's the object-oriented approach. And this was the sort of thing that David Parnas and other early computer scientists, or somewhat early computer scientists, had to think about and came up with wonderful ideas that we have to this day. So in the rest of this lecture, what we're going to do is start really thinking about how this would actually really look in real Java code and how it can be really useful to us.